Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This is a by request video for grade 9 academic students who want a little more help with rounding decimals. So let's see if I can help. First of all, a little talk about why we round at all. Have a look at this clock. If someone said to you, "What time is it?" your answer kind of depends on the situation. For example, let's say you're at a track and your friend is about to run around the track and he wants you to time him. Well, if you're timing your friend run once around the track, you're probably going to be pretty precise and have a look at the time and note that it's 8:48 and 21 seconds because he'll probably want to know precise to the second how long it took him. However, what if a baby's born? Well, when the doctor looks up to record the time of birth, he's probably going to record 8:48, but not the seconds. What if a stranger stops you in the street and asks you the time? You'd probably look at your watch and say, well, it's 20 to 9. Or you might say it's 8:40. But you certainly don't feel like you have to be precise because this person's on the street without their own timing device. So they probably don't need a precise, entirely accurate time. Or what if you're on the telephone with an overseas relative who says, "What time is it there anyway?" Well, you're probably going to say, "Oh, it's before 9," just to give them an idea about the time. Now, none of the answers you gave were lies. They were all accurate and they were all telling someone the same time. It was just a matter of precision. And that's the same idea about rounding numbers. When you were telling people the time, you were rounding. You were given different answers, different precision for different situations. That's the same thing we need to do in math. So for example, quite often, people like to talk about whole numbers. Um, round to the nearest whole number. So a whole number is a number without decimals in it, like 12 or 328. So we like whole numbers. They're also called counting numbers. So here's the idea behind rounding. We know that this number is at least 436. In other words, it got that far. It got to 436. The question is, did it get far enough past it that we should really consider it to be 437? So both of these are whole numbers. They're consecutive whole numbers. And our idea, our concept is this. If we ignored the decimals altogether, we know that we have 436. So the question is, did we get far enough past this number that we should really consider it to be 437? Well, the way you tell is you look at the first number that you want to eliminate. In this case, that number is a 7. None of these other numbers matter whatsoever. If I want the nearest whole number, then I know I need 436, but I might want 437. The way I decide is I look at the first eliminated number. In this case, it's 7. So let's think about it. We got to 436, and then we got this far along. We got to the 7. Now, you can tell that that's more than halfway. So the number got more than half of the distance towards 437, and therefore we round it to 437 because it got pretty close to 437, and it's closer to 437 than 436. So because of this 7, our answer is round up to 437. Let's try it again. Round to the nearest whole unit. So this is exactly the same idea as the last question. Nearest whole number, nearest whole unit. So that means I want no decimals in my answer. So have a look at this. And again, I like visually covering up what I don't need. We know we got to 72. The question is, did we get far enough along towards 73 that we're closer to 73 than 72? And again, the way to tell is to look at the first eliminated number. It's a 3. Nothing else matters, just that 3. So 72.3, so what does that mean? We got to 72 and we got this far along. Well, that's clearly closer to 72 than it is to 73. So in this case, we don't round up, we do what's called rounding down, and we call it 72. So 72.3 rounds to just 72 because zero point 0.3 is not close enough to 73 for you to round up. Now, when we're rounding using decimals, here are some of the words that you hopefully learned in a previous grade. You learned about the tenths column, the hundredths column, and the thousandths column, and so on. Now, most of the time in high school, we just simplify and say this is one decimal place, and this is two decimal places, and so on. So usually, if it's me, for example, I will say I want you to round to two decimal places. I very rarely use the term hundredths because it's kind of a tough question, a tough word to say out loud. Hundredths. It's way too many consonants in a row, and you don't even want to see my face when I try to do hundredths. It doesn't work very well. Anyway, let's look at how to round if decimals are involved. For example, round to the nearest tenth. So nearest tenth means one decimal place. So I want to round to one decimal place. So again, I like to cover up what I have. So here's one decimal place, which means I'm going to cover up everything below it. So all of this, I'm not going to look at. Now, I know I got to 6.5. So my answer maybe is 6.5. And the question is, did I get close enough to 6.6 that I should round up? So I need to look at the first number that I've hidden. It's a 5. Aha. So I got to 6.5, and then I got this far along. Well, the question is, if you got this far along, I'm not closer to either 6.5 or 6.6. I'm exactly in the middle. So what do? Well, the international math community made a decision. And the decision is that if you get to the halfway point, then round up. So because we're at 0.5, we're going to round up as if we were at 6, 7, 8, or 9. So we're rounding up, and therefore this should actually be 6.6 because we reached the halfway point, so we round up. Rounding to the nearest hundredth, again, that means two decimal places. So two decimal places. So therefore, I should have 127.73 is my minimum. And the question is, did I get far enough along that I should round to 7.4? So 127.73 or 127.74. And again, they're both two decimal places and they're consecutive. So 73, 74. So how far along did I get? So I look at the first covered number, it's a 2. Well, if I only got to the 2, I didn't get far enough for me to round up, and therefore we do what's called rounding down, and we leave it at 127.73, not 127.74. So those numbers were bad, but this is good. So again, 127.73, that 2 tells me don't round up, leave it as 127.73. Now, later on in math, in grade 10 and 11, you'll study something called trigonometry. And in trigonometry, along with a few other branches of math, we like to round to 4 decimal places. It has to do with precision, obviously. We need more precise answers in the world of trigonometry. So 4 decimal places, 1, 2, 3, 4. So I know that my number is 0.0398. And the question is it far enough along that I should call it the next number, which is 0.0399? And again, this 8 became this 9 because it's the next consecutive number if we use 4 decimal places. So to decide which one, I sneak a peek. 7. So the first number I eliminate is 7, and 7 is more than halfway along, so I round up to 0.0399. So in math, we sometimes round to 4 decimal places. In science, you will sometimes round to 4 significant digits. And a significant digit is considered a number that is not a leading zero. These are important because they're placeholders, but a significant digit is usually not a zero unless a zero is crunched between other numbers. So 3, 9, 8, 7 are your significant digits. So 0.03987. And the next one would be 0.039, oops, 3988, because it's just one unit more in the, what is that, hundred thousandths column? Good heavens. Now, which one is it? Reveal a 6. A 6 is more than halfway, so you should round up to 0.03988. So let's actually do a math problem involving rounding. It says the cylinder shown below has a surface area of 1600 meters squared. Determine the height of the cylinder. Give your answer to correct to 1 decimal place. So what's really important is if you are supposed to give your answer to 1 decimal place, then you should do your work with 2 decimal places. And that's kind of the rule, that you always work or keep your math with 1 decimal place more than your final answer. So my final answer I'll put in 1 decimal. Until then I'm going to work in 2. Now the other thing you need to know is you're going to get slightly different answers depending on if you use the pi button or if you use 3.14. Now, because this is a video on rounding, I'm going to use the pi button because it means I get to talk about rounding more. But it really doesn't matter which one you use. Just keep in mind you will get slightly different answers. So first we need to look at surface area. Surface area of a cylinder is 2 pi r squared plus 2 pi r h. So I know the surface area is 1600. And I know R is half of this, so R is 8. So sub in what you know. 1600 equals 2 pi 8 squared plus 2 pi 8. And then H is the thing I don't know. So again, I'm going to use the pi button so we can talk about rounding. So when I type in 2 times pi button times 8 squared, let me show you what I get on the next page. My calculator says this, 402.1238597. And I want 2 decimal places. So 2 decimal places is right here, 402.12, or do I want 402.13? Well, the first number I'm about to eliminate is 3. 3 is not more than halfway. It's less than halfway, so you take 402.12. So 402.12 plus, now 2 times pi, oops, 2 times pi times 8. Again, let's see what happens. I just got this in my calculator, 50.26548.246. I want 2 decimal places. So 50.26, but the first number I eliminate is a 5. And because it's a 5, then I take 50.27. So you'll notice I'm now sort of doing more of it in my head, which is hopefully what you can do as well. So I know I want 2 decimal places, so the first number I eliminate is a 5, which means I round up. So this is 50.27H. So now I'm just going to subtract 402.12 and divide by 50.27. So after doing all this math, this is what my calculator tells me the height is. Now I want 1 decimal place accuracy. So 23.8. The first eliminated number is a 2, which means do not round up. So 23.8 centimeters or meters is my answer. I hope that helped.